Okay, so have a look at this esophagus. So we are in white light, we are from afar, and you can see here very clearly that we have Barrett's esophagus, not very long. Part of this Barrett's esophagus is probably not circumferential. So you got it predominantly, but it looks a bit like a kangaroo with a kind of strange back leg. Anyway, the problem here sits for me around about what is currently at the 7 o'clock, but we can go in closer. Obviously it's cheating because I already had a look. So we just go in here and orientate ourselves, go into the stomach, come back, get the orientation. So probably now the greater curve is at 9, the lesser curve at 3. So we come back over the junction and have a good overview. So there's been acetic acid on here, which is well, not a huge problem, but certainly something going on there. So someone's taken a biopsy from this Barrett's esophagus and has got high-grade dysplasia. So sometimes, now the kangaroo's head is now at the 3 o'clock, so I think that is the true 3 o'clock. So just remember the kangaroo head to think about the position of what's going on here. So when we take this overview, maybe it's not so clear that there's anything really going on. We have got acetic acid from before, so we can really not rely on the acetyl whitening because potentially it was too long ago that it was there. But you can see the sort of regular glandular pit pattern you get in Barrett's esophagus here. Then when we have another look around, all this is nice and regular. Here potentially there's a different type of pattern, but it still looks regular. All this looking very regular. So all of this area is all looking pretty good with white light even. And because of the acetic acid, even though it was put on probably about 4 or 5 minutes ago, you still have the structure and you still see the structure of the glands. And then do you notice that the foot of the kangaroo I've not imaged? Because I think in the foot of the kangaroo there's something going on. How can we see that from afar? Well, really the acetic acid is not taken up so well in this area. And then when we switch for BLI, so let's just do that here. Again, the acetic acid structure really comes out at you and really looks very nice. You can see it beautifully here. That on the kangaroo's head, on the fingers of the kangaroo. Do they have fingers, kangaroos? On the kangaroo's hand, it is very, very regular. But there's something going on the kangaroo's foot. So if we just look here, you have an area of relatively preserved structure now at the 4 o'clock, and then in the middle of the screen you see something a little bit more disordered. So there is, if you just compare the right side of the image, the left side of the image, it's for sure not the same. The middle is much more disordered, and as we go in here, we can see the regular structure returns here on the leg, I guess, of the kangaroo. So the leg is regular, the foot, there's something really going on. And then to get closer, there are a couple of things we can do. We can use magnification in BLI. And so if we use magnification and get closer, we can see what's happening is we are just losing that ordered architecture. So the architecture moves from being ordered, bottom of the foot, ordered on the leg, into the middle of here where the structure is not particularly easy. If you look at the left side of the image, the 8 o'clock, there is some irregularity, but maintained structure. And then sort of in the middle of this image, the structure is kind of lost. So we are into regular, irregular, or regularly irregular. And I would say that the bottom right and the leg are regular. The bottom left is regularly irregular and the middle is irregular. So what does this mean? Well, this means that the cellular arrangement is disordered, the glandular structure is lost, and likely there is dysplasia or early cancer here. And then one of the other things that you very nicely can do is use underwater imaging. So the water shouldn't be high, maybe a little higher than this, but only a little bit, so that you get a thing. And you need a cap on for this, because if you don't have a cap on, it's very, very difficult. The patient's intubated, just so that you're aware that you shouldn't really be doing this in patients who are not intubated. And then we can really get this microstructure up. And you see it's pretty lost here. Like the structure is pretty lost. You see surrounding areas in the middle of the image, the structure is lost. The surrounding areas, it's lost. Sorry, surrounding areas it's maintained, but the center of the image it's lost. So this is an example, a very nice example of early adenocarcinoma in Barrett's esophagus. And I wonder whether there's one other thing that we should show. So we talked about characterization. Unfortunately, I just suctioned on it. We talked about use of acetic acid. We talked about structure. We talked about white light, but we didn't talk about LCI. And so I think LCI is a really nice detection mode. And let's just have a look and see together whether the kangaroo's foot stands out a bit on LCI as we do an overview. And I think you could probably say that it does. I don't think it's fair that we have done acetic acid here. I don't think it's really a typical situation. But as you pull back, you're kind of looking, and this zone is a little bit different looking than the rest. I think it's not fair because we've done acetic acid. So, summary, how to image Barrett's esophagus, combined use of acetic acid, and to be honest, best seen in blue light imaging, a early, not so big, probably 12, 13 millimeter cancer adenocarcinoma within Barrett's, characterized, and it should be removed for me using endoscopic techniques. Thanks very much for watching. Oh, we know access. Get carrots, maybe just 4 carrots, a reserve.